Alright, so here I will just talk about the simple thing of graphing sine and cosine functions. So if you recall, we covered through all the trig and the definitions of sine and cosine, and then we extended sine and cosine on the unit circle, so that if we have a unit circle and then we have a certain angle that we rotate by, then the x-coordinate becomes cosine, and the radius of the circle is 1, then the x-coordinate, after being rotated at this angle, the point that it intersects the circle is cosine theta, and the y-coordinate where this angle and this line at this angle intersects the circle is going to be sine of theta. So let's really quickly look at the graph of sine of theta. So here we have x and y, and then we have a circle where it gets rotated by theta. So theta is increasing counterclockwise. So 0 is the x-axis, and then 90 degrees is the y-axis. 180 degrees is the negative x-axis. Theta is something that rotates slowly around counterclockwise. So instead of looking at this xy plot, what if we looked at theta, along the theta axis? So theta is increasing here, so that means here, theta is 0. And then we look at the value of y, or this is the same thing as sine of theta. So how does this graph look like? Well, so it's pretty simple because we just need to look at, okay, theta equals 0 is going to be this line of 0 degrees, right? And then, here maybe theta is like 45 degrees or something, and then y is going to be, the actual sort of side of a 45, 45, 90 right triangle, and that's square root of 2 over 2. So, how do we actually plot it? So let's start. So, when theta is 0, okay, so let's just show this. When theta is 0, that means take this line and then rotate it 0 degrees. So that means keep the line exactly where it is. And this means y is exactly equal to 0, right? The y-coordinate is 0. The vertical distance is 0. So it is 0. Now, what is the next interesting point? Well, the next one is at 90 degrees, or at pi over 2, right? So 90 degrees, or at pi over 2. Here, sine of theta is completely this vertical distance, right? And remember the radius of the unit circle, because it's called a unit circle, is 1. So that means this vertical distance is exactly the radius of the circle, so it's equal to 1. So at theta equals 90 degrees, or pi over 2, we're rotating this one 90 degrees, y should be equal to 1. Okay, so this means that should be 1. And then what's another interesting point is at pi, right? So we're at 180 degrees. At 180 degrees, it becomes, this line here becomes completely rotated all the way here to this point. So the y-coordinate again becomes 0. So this is from 0 and then pi over 2, the same distance. So 0 to pi over 2 is the same as pi over 2 to pi. And this is going to be 0, right, because the vertical distance is 0. And then, okay, let's look at the next one. Is after 180 degrees, it becomes 270 degrees. So this line gets rotated all the way around to here. And now this is, again, the radius length, but it's in the negative direction. So at 270 degrees, or if you just add another pi over 2, another 90 degrees to 180 degrees, which is pi, it becomes 3 pi over 2. And this one is going to be negative 1. So this one is going to be at the point negative 1. Okay? And then, if we go all the way around to 2 pi, or 360 degrees, you'll see the whole thing repeats, right? So here, all the way at 2 pi, the whole thing repeats, and it goes back to 0. So you can actually fill in intermediate points, as I mentioned. So these are the obvious points because they're nice whole numbers. But of course, there's other interesting things that we may know. For example, for 45 degrees, it's going to be the sine of 45 degrees, which is going to be root 2 over 2, right? Because some sine length squared plus some sine length squared is going to be 1, so then you just try to solve the equation that gives you root 2 over 2. Because, okay, actually, let's just do that. So, for a 45 degree right triangle, these two angles will both be 45 degrees, so both these side lengths are equal to a, because they're the same. So that means that a squared plus a squared equals 1, or 2a squared equals 1, and a squared is going to be equal to 1/2, so a is going to be square root of 1/2, which, if you simplify algebraically, if you can say that it's root 2 over 2, right? Yeah, you can just square root 2 over 2, and you should get 1/2, right? Because square root 2 over 2 gives you 2 over 4. Square root of 2 squared is 2. 2 squared is 4, and that's 1/2. So that's why for a 45, 45, 90 right triangle, the sine of 45 degrees is root 2 over 2, because sine is this side a divided by 1, and a is root 2 over 2. So that means for 45 degrees or pi over 4 radians, it is going to be root 2 over 2, so it's going to be something like that. So now I won't go through the details. You can use a calculator or you can use a computer. If you graph sine, then it will give a curve that is quite smooth, and it will look like this. Okay, of course, it's not very nicely to scale, so these two should actually be even. This one should look exactly the same as this, except rotated around. So what are some characteristics of the sine graph that we can say right off the bat? One is that sine will always be between 1 and -1, right? Because if you look at it here, the y-coordinate will never actually exceed 1, since here it's maximum, and it's 1, and then here it's minimum, and it's -1. So sine always goes between 1 and -1. So sine should never exceed 1 and should never be less than -1. So keep that in mind. If you find the sine of some angle when it's actually bigger than 1 or less than -1, it means there's some computation error, and you can check that really easily. So sine goes between 1 and -1. Furthermore, when you go to 360 degrees, the whole cycle repeats. So when you get to 2 pi, it becomes the same thing as just 0 degrees, right? So from here, I can essentially repeat the same curve over again. It keeps on repeating to infinity. Similarly, if we have 0 degrees, we can even rotate it by a negative angle, which means rotating it clockwise. And then, the same wave will repeat this side, and so on. So that means it's a repeating wave, and this is sort of the critical part that's being repeated. So this is the part in the pattern that gets repeated from 0 to 2 pi, and this is the graph of sine of theta. So this is great. So now how about cosine of theta? So actually you can go through the same argument, starting here and only look at the x-coordinates. So then, when theta is 0, x is maximum, it's 1, and it's here. So if you just do real quick, so the cosine theta, and this is theta, then, okay, so for cosine theta at 0 degrees, the x-coordinate is going to be 1, right? It's like the maximum horizontal distance. So at 0, it's 1, and then if you just work through it, find that at 90 degrees, it's 0. At 180 degrees, it's -1, and then at 270, it's 0 again, and then at 360, it's going to be 1 again, because it repeats. So then you get a curve that looks like this, and then of course it repeats. So one thing you'll notice is that the cosine curve and the sine curve are almost exactly the same, except one is sort of shifted this way. So cosine is like sine, shifted this way a little bit. And actually, we already have an identity. I already discussed an identity briefly that explains why that is. Because if you have a right triangle, this is going to be angle theta. This is going to be actually 90 degrees minus theta, so that's going to be pi over 2 minus theta. And actually, yeah, so this means that, the sine of this angle, which is a over c, is going to be the same as the cosine of this angle, which is going to be also going to be a over c. So that means sine of theta is going to be cosine of pi over 2 minus theta. So this shows that, cosine and sine are almost the same function, except cosine sort of shifts the thing over a little bit. Actually, this is not exactly true. If you put a negative sign, it means you flip the graph around, but since the graph is symmetric, when you flip it around, it's the same thing. And furthermore, when you add pi over 2 to this negative theta, then it shifts the graph over. So you flip it around and then you shift it, and that gives you cosine of theta from sine of theta. So these are the graphs for sine of theta and cosine of theta, and this is where it comes from. Just look on the unit circle, plot a whole bunch of points for theta, and then you will get the graph. And remember, it's always between 1 and negative 1 for both sine and cosine, of course. So everything is within the circle, and everything repeats. And everything is going to repeat up to 360 degrees, because once you go 360 degrees around the circle, it's going to be the same thing again. And this is the unit circle and how the corresponding graphs for sine and cosine are generated from it.